If you've ever built an app, you are very familiar with that constant dance of getting data from a server, right? Sometimes you get this giant mountain of data and it just slows everything down. Other times you don't get enough and you have to ask again and again. For decades, we've just kind of worked around this, but what if there's a better way? Let's dive into how APIs are evolving and explore this really powerful query language that is completely changing the game, GraphQL. Now, this quote is from a developer who literally wrote the book on the traditional API method we've all been using. So when a diehard expert like that starts looking towards the future with GraphQL, you know a major shift is happening. This isn't just about a new trend, it's about a fundamental change in how we think about data.
So, why the big shift? I mean, to really appreciate the solution, we have to get into the problem, this data dilemma that honestly most developers have run into, even if they didn't have a name for it. And let's be super clear here. The traditional approach, what we call REST, is not bad at all. It's the bedrock of the modern web. It's predictable, it's scalable, and for years and years, it was exactly what we needed. It got the job done, and it did it really, really well.
But as our apps got more complex, especially on mobile, some cracks started to show. And the core issue really just boils down to inefficiency. With that traditional REST approach, trying to get just the right amount of data is a constant struggle. You either get way too much or you get frustratingly little. And this slide just illustrates the two sides of that coin perfectly. So on one hand, you've got overfetching. You ask for a user's info, and the server sends back everything, their name, address, phone number, their entire purchase history, when all you really needed was their username. It's like ordering a 7-course meal just to get the dessert. And then, on the other hand, there's underfetching. You ask for a blog post, but then you have to make a totally separate request to get the comments, and then another one for the author's details. It's just inefficient, and it makes everything feel slow.
It was this exact data dilemma that pushed the developers over at Facebook to a breaking point way back in 2012. It was a huge problem, especially with their mobile app. So their solution wasn't just some small fix. It was a completely radical new way for apps and servers to talk to each other.
Okay, so it's really important to get that GraphQL is two things at once. First, it's a language. It lets your app describe with incredible precision the exact data it needs. And second, it's a runtime that lives on the server. It's like an engine that takes that very specific request and just seamlessly gathers the right data from wherever it lives, whether that's a database, a microservice, or even another API.
And look, this isn't some fly-by-night technology. It was born out of a massive real-world need at one of the biggest tech companies on the planet. After being battle-tested inside Facebook for years, they open-sourced it, and eventually its governance was moved to the neutral territory of the Linux Foundation. That really solidified its place as a new industry standard. Now, this leads to a fundamentally different architecture. With REST, you usually have this sprawling collection of endpoints, right? You've got /users, /posts, /comments, and on and on. GraphQL just simplifies all of that dramatically. You get one single intelligent endpoint. That's it. All your data questions, from the simplest to the most complex, go right through the same front door. Okay, so how does this actually work? I mean, how can one single endpoint handle everything? Well, it all comes down to just a few core concepts that make up the GraphQL toolkit. Let's break them down. The absolute undisputed heart of GraphQL is the schema. You should think of it like a strict, super detailed map of your entire data universe. It defines every single object, every field, and every relationship possible. This schema becomes the single source of truth. It's a contract that both the client and the server have to honor. And that means no more guessing what data you can ask for. If it's not in the schema, it doesn't exist. Simple as that. So with the schema as our map, we can now write a query. And this is where the magic happens. A query is just your app asking for data. But here's the key. Unlike REST, the query structure looks exactly like the shape of the data you want to get back. You ask for exactly what you need, and you get exactly that. Nothing more and nothing less. So instead of just asking for a user and getting everything, you can say, hey, give me the user, but I only want their name. And for that user, give me their last 3 blog posts. But for those posts, I only want the titles and maybe the comment count. It's this incredible level of precision that solves both overfetching and underfetching in one beautiful, elegant move.
Right. That makes sense. Querying is fantastic to reading information. But our apps aren't just read-only, are they? We need to create stuff, update things, delete things. So, yeah, how does GraphQL handle that? Well, it has a very clear and distinct way of handling all those operations too.
It's actually pretty simple. While queries are for reading, mutations are for writing. Mutation is just GraphQL's name for any operation that changes data, creating, updating, or deleting. And what's really cool is that they're structured just like queries, which means you can modify data and ask for the new updated state of that data back from the server, all in a single efficient trip. Okay, so we've got the building blocks down, but what's the real-world payoff here? Why would a developer or a whole company choose to invest in building a GraphQL API when REST already exists and it works? Let's talk about the advantage.
The payoff is that GraphQL directly solves the exact problems we started with. There's no more wasted bandwidth from overfetching, no more sluggish apps making trip after trip to the server to fix underfetching. You get a single, predictable endpoint to manage, and, this is a big one, the schema itself acts as live, self-updating documentation for your entire API. That is a massive win for developer productivity.
So does this mean REST is dead? Absolutely not even close. It's about using the right tool for the job. GraphQL totally shines in complex, interactive apps with constantly evolving data needs, like, say, a modern social media app. But REST is still fantastic for simpler machine-to-machine communications, like internal microservices. And there's a trade-off. GraphQL can be more complex to set up on the server, but it provides a way better, more flexible experience for the client that's actually consuming the data. And that right there is really the key takeaway. Technology is not about dogma. It's about having a versatile toolkit, knowing when to reach for the simplicity and reliability of REST versus the precision and power of GraphQL. That's what separates a good developer from a great one.
So is GraphQL a replacement for REST? The answer is no. It's the right tool for a new era of challenges. What it really represents is a power shift in that conversation between the client and the server. From the server always dictating the data, to the client demanding exactly what it needs. And as our applications get more data-rich and more interactive, that shift isn't just an advantage, it's the future of building for the web.